Hi everyone, we're in Unit 1, Day 1 Notes. We're going to start talking about graphing and analyzing functions. This is kind of a two-day thing, so we're going to do the first part right now. This unit is all about quadratic functions, so let's go ahead and start talking about them. Well, what is a quadratic function? Let's kind of identify this as a parabolic shape. And what that means is that it's going to look like this kind of U-shaped picture here that I'm drawing on the side. Whenever we're talking about a quadratic, we're going to be talking about a parabola, and that's where that word comes from. There are three forms of a quadratic function, so I'm going to go ahead and highlight all these. The first one is vertex form. The second one is intercept form. And then the last one is standard form. All super important. We're not going to do too much on these forms right now today, but we will start talking about those very soon. Okay, let's get to some vocabulary here. The first word is parabola. This is the shape of all the quadratic functions. So again, a parabola is this U shape. We can have a parabola opening up, or we can have a parabola opening down. The next thing is the vertex. So on a parabola, so let me draw you one going up. We have this point called the vertex, and it is all the way kind of at the bottom there where you have a change of direction. It's either the highest or the lowest point. So I'm going to label that with a V. We can have it going the other way. Let's say the parabola is opening down. This time my vertex is the highest point all the way up here. I'm going to label that a V for my vertex. Next we have maximum or minimum. And it really is exactly what that word is saying. If I have a parabola that is opening up looking like a U here, at the bottom I have a minimum. That is kind of like my lowest point. So next to that word minimum, why don't you write the word low? Your smallest value. And then on the other side of things, you can have a parabola opening down, and you could have on the top here a maximum point or a maximum value. And next to the word maximum, why don't you write high, or kind of like biggest value. Okay. The next are x-intercepts, roots, solutions, and zeros. This one is kind of tricky for some people. That I'm going to circle because those are all words that mean the same thing. Okay, so don't let that confuse you. This is a value of x that makes y 0, or think about it as the point where the graph touches or crosses the x-axis. Okay, it's just like an x-intercept that we've been talking about. So if I give you a little graph here, I'm going to put a parabola on it. So there's my parabola. My x-intercept, my roots, my solutions, my zeros are just these points right here where it crosses the x-axis. Okay, so this is an example of an x-intercept, and we talked about that last unit. Okay, next we have y-intercepts. This is the value of y that makes x equal to 0, or we talked about this before, is where the graph touches or crosses the y-axis. So again, let me draw you a little graph here, and let me put a parabola on it, just like that. The point we're looking for is where it crosses the y. In this case, it's crossing the y right at my point. We call that the y-intercept. Something to keep in mind with the x and y intercept, I'm going to write it over here on the side. We always write those as ordered pairs, kind of like as x, y coordinates. These are always as ordered pairs. The last thing I want to talk about is end behavior. End behavior describes what is happening to the graph at each end. So again, let me give you a little parabola here. Go ahead and draw it in. What we're looking for is the end of my graph. So right there where I have it circled, kind of where those arrows are pointing, think about that. We're looking there for the end behavior, the end of those lines. Okay. Next we have interval notation. When we describe where a graph is increasing or decreasing, we use interval notation. And let's just kind of get a few things down about this. So looking at my first graph right there on the line, I have some open circles. So let's go ahead and just label those so you know what that is. We have an open circle. Okay, and then if I look at my next graph, I have a little bit different of a situation. This next one, I have a closed circle. And then that kind of goes on the whole time. An open one, a closed one, then I have two closed circles. Well, what does this mean? So let's go ahead and fill in this first blank. Open circle means that a number or a value is not included. Okay? It means we do not include it. It isn't a part of our answer. Okay? This also means that it gets a parentheses. So I'm going to put a set of parentheses there. Then we have another situation, which is a closed circle. If it's closed, it means it is included, which means this time we get brackets. So I'm going to draw a set of brackets. Kind of a way that I like to remember it, and I'm just going to write this off to the side. If you have a greater than symbol or a less than symbol, you automatically have an open circle. With that, you also have a set of parentheses. So those are like best buds, all those go together. The other way is if you have a greater than or equal to, less than or equal to, you automatically know you're going to have a closed circle. If you ever have a closed circle, that goes with brackets. Again, these four are like best friends. Okay, that's kind of just an easy way for me to draw it and remember it. Okay, underneath that it says we can never reach infinity. Infinity is that symbol right there. And if we can't catch something, then we can't include it. Therefore, infinity will always have a set of parentheses when using interval notation. So whenever you have this infinity symbol, you're always going to have parentheses. You really don't even have to think about that one. You're always going to have parentheses. Let's practice with example 1 right below here. It says, suppose we want to describe the following using interval notation. When using interval notation, you read this number line like a book, left to right. Okay, I see that my line is starting right here at -3 and it's ending at +3. At -3, I have an open circle. If I have an open circle, that means I have parentheses, and it picks up at that -3 value. It's going all the way until +3, and at +3 I have a closed dot, so that means I have parentheses at that value. And that's all we're saying, from left to right, what's happening, what numbers do I include or not include. Okay, next topic is increasing and decreasing intervals. A function is increasing if the x values increase left to right, then the y values increase. A function is decreasing if as the x values increase, then the y values decrease. Okay? Kind of confusing. Let's look at a visual. I think that'll help you and make a little bit more sense. On this visual, I'm going to write a couple of things and then we'll answer this question on the right. Give the increasing and decreasing interval. Couple things. On my graph, on the left, it always is -infinity over here. It gets super small on the left. And on the right, I have positive infinity. It gets really big on the right-hand side. Okay, couple things to point out. I have a maximum up here where I'm putting my blue dot. Okay, my maximum is my highest point. That's kind of the spot where my graph is getting cut in half, like right in the middle. Okay, right in the middle there. Otherwise, let's go ahead and start talking about finding increasing and decreasing intervals. Kind of a nice easy way to do this is always remember to start over here on the left. If I do that, I'm going to pretend like I'm riding a roller coaster. So I hop on the roller coaster and I follow my graph, and all of a sudden I am increasing. Okay? Imagine you're riding a roller coaster. You're riding up, up, up until a certain point. Okay, that's your increasing piece. So for my increasing interval, I want to write I'm increasing from -infinity, from super small over here, all the way until I get to, and this is where it's tricky, all the way until I get to -2. Okay, and the reason I picked -2 is because I always use x values. Okay, so let's also make note of that and put a star here. So let's say look at x values. All right, then I'm on my roller coaster and I'm up, 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 and I get to the top and I'm about to go down this hill, right? So then I go all the way down, and then imagine that this is like your stop point. Okay, so I rode my roller coaster all the way down. So I started at my x value of -2, and I rode it all the way down. And again, I'm looking at x values, so I rode it all the way down to positive infinity. Okay. All we're going to do is run through 3 examples. Go ahead and pause or kind of stop the video if I'm moving too fast. The vertex is the lowest or highest point. That's my blue dot. Write it as a coordinate. That would be 5, 3, a normal xy coordinate. We have to pick if it's a minimum or maximum. In this case, it's our lowest value, so I'm going to go ahead and circle min. X-intercepts, always as points, is where it crosses the x-axis. In this case, it doesn't happen. We have no x-intercepts. We also have no y-intercepts, or we can't see them on this chunk of the graph. Okay, so we're going to say none for both of those. Increasing and decreasing interval, where it gets a little bit tricky. Again, this is -infinity and this is positive infinity along my x-axis. I want to start on the left-hand side and I ride my roller coaster down. So this time I start to decrease. I decrease from -infinity until whatever the x value is, so that is until +5. Then at +5 I kind of have a turning point and my ride starts to increase. I start going up from 5 to positive infinity. Okay, so if it helps you, maybe put like a little I here for oops, back up. Put a little D here for decrease, and then put a little I here for increase to help you keep track of things. Now, the next thing is a little bit new. We haven't talked about this yet. Let's go through it. It says as x approaches -infinity. So as you look at the left side of your graph, where is y approaching? So follow my cursor. So as I look to the left of the graph, okay, where is my y approaching? Okay, that's all you're thinking. In your mind, you probably were thinking, oh, it's going up, right? That's where I circled. But we don't write the word up. We're going to go ahead and use positive infinity. Now the other one, as x approaches positive infinity, that's from the right side. So as we're looking to the right, where is y going? So as I'm going to the right side, where is my y going? And that's my other side of my graph. Again, you probably were thinking, oh, it's going up. But we don't write up, we write positive infinity. Let's see if I can get in these other examples. Example 3. The vertex is all the way at the top this time at -2, 4. It's the highest value, so that's a maximum. X-intercepts, where it crosses the x-axis. I have 2 spots here. I labeled those in red. Okay, it's at -4, 0, and I have another one at 0, 0. My y-intercept is also that red point right here where I'm circling. My y-intercept is 0, 0. Increasing and decreasing, here we go. I'm going to put -infinity and positive infinity on my graph, and I'm going to ride up my roller coaster. That is increasing because I went up my roller coaster. Then all of a sudden I have a change of direction at -2. So I'm going to increase from -infinity, and then I'm going to kind of stop at -2. Then all of a sudden I decrease down my roller coaster from -2 to positive infinity. Now I have my end behavior. As x approaches -infinity, so again, look at the left side. As x approaches -infinity, where's my y going? Well, my y is pointing, and you're probably thinking, oh, it's pointing down. Well, it is, but we don't write down, we write -infinity. And as the right side approaches positive infinity, so as we look to the right, my y value, my graph is pointing again down, but let's write negative